Hey buddies, welcome into the paper 2 touch-ups where we talk about the things that you need to know as you prepare for your second exam. Now, as per requested by Mr. Kotseli, shout out to you Mr. Kotseli, in today's video we'll be looking into trigonometry 3D application. So if you're new to the channel, please be sure that you subscribe so that you won't miss when another video gets uploaded. So without further ado, we're going to jump straight into the things that you need to know as you prepare for trigonometric 3D problems. Now, whenever you're encountering 3D trigonometric problems, the first thing that you need to know is that you need to be always isolating your triangles, right? A 3D shape, it is a 3D shape made up of 2D shapes. So there, whenever you're given a structure, the first thing that you need to do is to check for your right angle triangles and write those triangles, and check for the non-right angle triangles and write those ones. On the right angle triangles, you need to understand that the only things that you're going to be using to either calculate a side or angle is going to be Pythagoras or trig ratios. And on the other side, which is the non-right angle triangle, the only thing that you're going to use is a sine rule, cosine rule, or area rule. Now, before I can move on, I want to tell you the difference between when you know you're supposed to use a sine rule and a cosine rule. So let me just add all right. So now here I can see that here the first things first is a sine rule. So how do you know that you are supposed to use a sine rule? So in the diagram, if you know what is an angle, for example, if you are given an angle, right, and you have the side, let me just call this side E, right, and then after that you have another side, for example, another side, we call it F, and then you're trying to find this one, which is F, right? So you have this and that, but you want to find the angle. So because of this, that means now you can be able to calculate what? You can be able to find a sine rule, or you can be able to calculate F using the sine rule. Now, what about the cosine rule? The cosine rule and the area rule, they work the same way, right? In a cosine rule and an area rule, what happens is you will need to have an angle, right? In the diagram, you'll see that you have an angle, and you see that this angle is formed by this side, right, and this side, right? So if you have this value here, let me just call it A. If you know what is this value of this side and this value of this side, then this means now here you can apply what? A cosine rule to find that side. I hope this makes sense. Let's go ahead and look into the question so that I can be able to show you how you can basically solve any 3D problem that you're going to be encountering. Now let's look into this question here. The question goes as follows. AB is a vertical tower of P units high. D and C are in the same horizontal plane as B, which is the foot of the tower. The angle of elevation of A from D is X, and BDC is Y, and BCD is theta, and the distance between D and C is what? Is K units. Alright, as you can see now, everything that we're told here, it is already in the diagram. Now the first thing that you need to do is what? Is isolating the triangles. Now let's look at for the right angles. So I'll just call it right angle. Now the right angle triangles here that I see is triangle ABD. Now why do I call it the right angle triangle? It's because it contains an angle here which is 90. And then now here, what about the non-right angle? So the non-right angle, I can just say non-right. The non-right angle is triangle BCD. So this means now here in this non-right triangle, I can use what? Sine rule, cosine rule, and what? An area rule. Now that I have that in order, I can go ahead now and answer my questions. Now the way that I'm going to ask my question is I'm going to look for what they're asking me, and I'm going to see where it is located, right? Now for example here they're saying express P in terms of BD and X. So now here basically what they want me to do is they want me to calculate P but using this value and this value, right? So this then means now if I want to calculate that, I'm going to look into triangle ABD. Now what is triangle ABD? If you remember, triangle ABD is a right angle triangle. So this then means now if you want to calculate P, I can see that I have an angle X, and then that angle X, I can see that P is an opposite to that, right? And then BD is going to be what? An adjacent with reference to X, right? So this then means if I want to calculate this, I'm going to use the trig ratios which is, let me just write the trig ratios here. So Katoa. So the trig ratio that I'm going to use that has both an opposite and an adjacent is going to be 10. So this then means now I want to say 10x is going to be equals to, my opposite is going to be p over, and then my adjacent is going to be bd. Then if I'm solving for p here, this is bd 10x, right? So now basically the easy way for doing this is stop trying to prove something and just try to solve something based on what you're given, right? And then with whatever that you're given, just look at what things that you're given and then just calculate that, right? I hope this makes sense. But I think it's going to make more sense in the next question, which is this one, which says hence prove that p is equal to that, right? Now here, if you remember, we know that p is bd, right? 10x. Now basically they saying now they want us to show that, or to prove that p can be that value. So now if you look into this value, which the p that we have here and the p that they have here, we can see that we have 10x here and they also have 10x there, right? So which means now here basically what they want us to do now here, they don't want us to prove this, they want us to solve, to simplify what is bd, right? So to do that, we want to look into bd. Now bd, can you see where bd is? You can see there is bd. Let me just point it. BD is in triangle BCD, right? And then this is where we have a lot of information there. Now in triangle BCD, I have this angle y and this angle theta. Now if I have two angles in a non-right angle triangle, it is very important that you always find the third angle also. So here we're going to say now in triangle BCD, right? I know it's a non-right angle triangle. First things first, I want to calculate that angle, which is DBC. Now DBC is going to be 180 minus the sum of the two angles that I have, right? And then now that I know this, I know that I have this angle also, right? So I have this angle, and then this angle is pointing this side, and now I have this angle also, and this angle is pointing on the side that I want to solve. Then this then means I can find what is BD. Now BD over sine C is going to be equals to DC over sine DBC. So here, what did we do here? We used what? We used a sine rule. Remember, in the sine rule, I said that to know that it's a sine rule, you need to have an angle. In a non-right angle triangle, you need to have an angle, then that angle needs to have a side. And you need to have another angle, and then the side that you want to know. Sometimes it can be this side, but you wanted this angle, so it means you can apply that, right? So let's see here. If I'm isolating BD, I get BD as, sorry, I have two equal signs now here, DC sine C over sine DBC. Now if I'm simplifying this, I know what is DC. DC is K. I know this is K sine, and then C is theta over sine, and then DBC is 180 minus, y plus theta. And then if you simplify this, this is a reduction, right? Simplifying this is going to be K sine theta over 180 minus, in the second quadrant, sine there is positive, so it's going to be sine y plus theta, right? And that is just BD. And so P is going to be, substitute BD, K sine theta over sine y plus theta multiply by 10x that we have there. And then now we can see that sine y plus theta is a compound angle, so I'll multiply the numerator, sine theta 10x, and over, then there's a compound angle, so it's sine y cos theta cos y sine theta, and then that's basically exactly that answer. So without even looking at that answer, because of you knew how you applied and you used the rules right, this answer is going to be definitely that one, right? Without even checking it. All right, so I hope this makes sense. Let's go ahead and look into the third one. Now the third question, which is the final question, it says find BC to the nearest meter if x is 51,7, y is 62,5, and p is 80 and k is 95. All right, so now here, what is it that we're given here? We're given y, we're given x, we're given k, and we're given p, and they want us to find this one, right? Now, do you notice here that they didn't give us theta? So, most cases, whenever you have proven something in the previous question, it means now you're gonna use it in the next question. But here they didn't give us theta, so it means now we cannot use p to basically solve for what? For BC, which means I'm going to create a new equation for what? For BC. Now, to do that, we're going to look into what we're given. So here I can see that I have, in the triangle BCD, currently I have DC, right, and this angle here, right? And then I don't want to play anything closer to theta because I'm not given what is theta. And then now here I can see, now the only thing that I'm left with here is to find, what? Is to find, let me just write it here, is to find DB. Why do I need to find DBs? Because if I can find DB, I see that I have an angle and I have two sides, and those two sides, if they are known, then it means I can easily find what? I can easily find BC using a what? A cosine rule. So let's see if we can find BD using triangle ADB. Yes, we can. So how are you going to do that? So if you remember in the previous question, right, we said that DB, we said that DB, well, we said AB was equals to BD 10x, right, which was on the first question, which is 6.1.1, right? And in 6.1.1 we said AB was DB 10x. So this means now DB or BD can be AB over 10x. Now let's substitute that. So what is AB? AB is P. So the value for AB here is what? It is 90. It is 80, sorry. 80 over 10. Now what is x here? X is 51,7. Now if you press that in your calculator, you get your value of BD as 63,18 degrees. Then now you have what? Let's take this. Now I have this one and this one and that one, and that is a cosine rule. So a cosine rule says, now if I want to calculate BC, I'll say BC squared is equals to DB squared plus DC squared minus 2DB times DC cos of the angle facing BC, which is going to be BDC. Now you don't need to memorize this formula because it's going to be at the back. So now here, if I'm isolating BC, I can see that BC is going to be the square root of everything here, squared minus 2dB DC cos of BDC. So let's go ahead and substitute there and then press everything on the calculator. Now dB we just calculated now, it is 63,18 square plus DC is K, and then they said K is 95 squared minus 2, 63,18, and then 95 times cos, what is BDC? BDC y is 62,5. Put all of that on a square root. So if you can press all of that into your calculator, you're gonna get an answer of 86,45 meters. That is rounded up to 2 decimal, and then now this is basically going to be, remember the question it said we need to round it to nearest meter. So basically our answer here is going to be 86 meter, because we run it up now. So that's all I got for you today. If you like the video, please make sure that you like, share it to your friends so that they can be able to see this variable information, so that they can also be prepared for the upcoming exam and the question in the trigonometric 3D. And I'm going to see you on to the next one, where we'll be looking into a different topic. Cheers.